Hey welders, welcome back to the channel. I'm your host, WhiteRiverRambo for Weld.com, and today we get to take a look at the brand new Alphacut 825I from AHP. Let's get this box over here on the table, open it up, get all the parts laid out, and then we'll talk about all the great features of this plasma cutter, as well as show you how to set it up. And here it is, the AHP Alphacut 825. Man, what a great looking machine, right? Black and yellow, black and yellow. You can roll it around the front, see what that looks like. We'll get into that here in just a second. But we really need to start right here in the back. Now on the back of the machine, you can see I already have the water trap mounted. You guys can pretty much handle that. It's 2 screws, a bracket, and then 3 plugs. One of the plugs is a air chuck that you're going to hook your air line up to, a air plug, just a brass shutoff, and then the shark fitting that goes on the out port of the water trap. And the last thing we have to do is have some 5/16 clear line here, 5/16 OD. I'm just going to clip the end of it to make sure that that's straight, and then make sure that I've got enough, give myself a little extra, cut it off, take it and simply push it into the shark fitting till it seats, and it should be good to go. We'll go ahead and hook this up down here to the machine itself, and the back of our machine's set up. Now let's turn it around and look at the front of the machine. Now the front of the machine is pretty self-explanatory as well. On the left side of the machine, you have a digital readout. That's going to tell you what error codes that you're having, as well as the knob underneath is your power knob. You know, how many amps are you running on whatever thickness you're trying to cut. As we move across, there are 2 buttons down here, auto restart and the tip saver. Now that's going to be like if you're cutting solid metal, or if you're cutting, say, expanded metal, you might want to put on that auto restart feature. That way you can continue to cut and not have any problems. Another button over here on the side is normal or air check. If you're wanting to check your PSI, make sure that you're not having a drop in your air system. When you turn the machine on, you can put the machine in air check and hit the trigger, and it won't try to start an arc. It just allows you to check the air side of the machine. And then over here on the right, of course, we have our dial indicator to tell us how much PSI we're running. The machine recommends somewhere between 60 and 72 PSI, and you would set that by the knob that's on the top of the water separator back here in the back. It has an air regulator built in. So I would suggest set your compressor up to 80 to 100 PSI, and then once it comes to the machine, regulate it to about 70 PSI, and you should be good to go. One last knob is right in the center, and that is your post flow. Probably the most important thing of the whole machine is making sure that your consumables cool off after the cut is finished. The lifespan of consumables depends on how much heat they're dealing with. So if you have a long cut, you want to turn that post flow all the way up. But if you want to conserve your air, and you're just cutting body panels or, 20 gauge steel for that matter, then you can turn that post flow down because your consumables aren't running near as much amps, and it won't require as much cool air to cool off the system. Now hooking up the machine's pretty easy. You can see down here in the bottom we have a work lead hookup and a torch hookup. Now our work lead, a pretty nice piece of wire, okay, nice heavy ground clamp, all right, just a braided copper in between the two, which is nice, and then a small DINS connector, which just goes right into this side and turn a quarter turn, and we're ready to go there. Now on the torch itself, the hookup has an indexing tab, and we'll just simply push that into the hole that's faced at 12 o'clock, go ahead and tighten up our torch, And the only thing we're missing right now is 80 psi, so I probably need to go ahead and turn on my air compressor. One very important thing that we need to consider is moisture or water in your compressed air. Now, we all go through this. It's a big problem for everyone, but the worst enemy of a plasma cutter is moisture in the lines, okay? It can be almost dangerous, as well as ruin your consumables very quickly. Now you see here I also have a bead style moisture dryer, as well as a water trap here and a regulator, and then on the outside of the building next to my compressor I have another water trap. So that is 3 lines of defense before I go to the machine, and that water trap that's on the back side of the machine is a last resort to make sure that no water goes to my machine. Now currently we have our regulator set to 90 psi, and that should feed our machine rather well, seeing as how we only need 70 on the back of the machine. One of the biggest attributes of the Alphacut series is the ability to run dual voltage. Now, if you do have a 240 volt outlet like we have right here, I strongly suggest you use it because you're going to be able to get the full 60 amps out of the machine. But what happens if you need to be mobile and run on a generator? Or maybe you need to do some work at a buddy's house and his barn doesn't have a 240 volt outlet? Well, with the dual voltage adapter, we can go ahead and run a standard 120 volt outlet. Now you should never try to use 120 volts and an extension cord. The amperage is just much too high. You could cause fires, you could have a short, and you could do damage to the machine. Okay, so we've run our air line to the back of the machine. Go ahead and plug it in. And we are on 120 volts. Let's go ahead and reach back here and turn our machine on. Okay. Let it cycle just a little bit. All right, and the display reads EO6. Well, that's because we haven't set our regulator yet. Now, this is where the air check feature comes in pretty handy. I'm going to click that until it comes on, and then I'm going to reach back here on my regulator and start cranking up the pressure. There you go. Once we get above 20 psi, the air check feature begins to run air through the torch. See, I got the torch laying right here, and that allows you to monitor how much the system runs air. Now, right about the time I hit 60 psi is about the time where the needle stops moving. I can go ahead and turn this air check feature off and the needle jumps up to 80 psi. So don't get caught up a whole lot if your needle stops at 60 psi. Some of that is the restriction of airflow within the system. As long as you get above 60 psi, you should be totally fine. Next up, we need to look at machine settings. Now, you see we got a 20 right here on our dial. Now, mind you, I'm on 120 volts, okay? So turned all the way down is 20, and turned all the way up is 30. That's the maximum amperage that I can get out of 120 volts. Even though the board right here says 20 to 60, it's not marked for dual voltage. So I'm going to start with some 14 gauge material, and I think we can cut that with 20 amps. So we're going to start with 20 amps, and then on our post flow, I'm just going to set it right here about 30. That's probably a little excessive, but I don't care because I would rather burn up a little bit of air compressor volume than I would burn up some consumables. Let's get some gloves on and see about cutting some steel. Now this small piece of scrap, you can see how rusty it is and dirty. I'm not going to do anything to it. I know how you guys are going to treat this machine, so I'm not going to treat it any different. 14 gauge cold roll. I got a piece of high heat polymer here. Give me a little bit of a guide, and let's just run the arc across here and see how it performs. Yeah, buddy. All right, so we got some 2-inch square tubing here. Looks like it's 1/8 wall, maybe 3/16. We're gonna turn up to 30 amps here and see how this pilot arc and everything works on this square tubing. Yeah, buddy, I like it. All right, you ready for this? We're gonna up the game a little bit. How about some 1/4-inch angle? Now, mind you, we're still on 120 volt. Let's just come right down through here, clip this off. Rusty as can be. I'm not cleaning nothing. Let's try it. Well, it did it. All right, enough playing around. Let's really get down to business and see what this little thing's made out of. Let's drop down to 240 volts and see how she does. Same as before. Make sure our settings are good. This time we're getting to a little bit more heat, so I'm going to turn my post flow up, and then we're not going to start at full capacity. Let's just do that same cut, but we'll do it at 40 amps and try that. Shoo-wee, what a difference, boy. Hell yeah. Wow, look at that. There's not even any dross there. That looks pretty good. I don't do this very often. And freehand on that, that's as straight as an arrow. That's straight enough to weld in my shop. Let's get some aluminum out. I want to try some alloys. So aluminum is quite a bit different than steel. It doesn't cut very clean, and it generally takes more amps to cut. So 1/8-inch aluminum, let's try 30 amps. Wow, look at that. Look at that. Now there's a little bit of dross there, but that is nothing that a flat disc can't take care of. Now the reason why I never do this or never use a plasma cutter to cut aluminum is, well, frankly, I can cut this with a skill saw and a non-ferrous blade very quickly. And it's very clean that way. Aluminum cannot have any contamination in it, and the plasma cutting process is full of contaminants. So if I need to, like if I have to cut a curve or something, the plasma cutter is definitely a good choice. However, it will have to be cleaned very, very well before I can weld that. But I like it a lot. Let's grab something thicker. I've got a piece that's 3/8 webbing here. Tell you what, I'll just run it right across here. Short section, what do you think? My Lord, that's good. No dross. None. Well, I wasn't going to do this, but man, with those type of results at 45 amps, let's try some 1/2-inch aluminum. I can't believe I'm doing this. Let's just go ahead and crank it to 60 because this is going to eat up some power, I'm here to tell you. And instead of going straight this time, I'm going to go a little bit of a curve and get fancy. Wow, kids, that's legit. Now I realize not the whole audience will understand how much power that takes, but as you saw at the start of the arc, it was like really struggling. And then once that aluminum sinked in a little bit of heat and she shot down through there, I was able to go at a pretty good rate. We'll go back to steel here next. All right, let's get back into some steel. Now, here's an old piece of 3/8 that I had, and you can see back when I used to cut things with a torch, or I had to. That was a long time ago. I haven't seen this piece of material in a while. I tell you what, let's try 45 amps. I'm not gonna make nothing fancy here. We'll just make a couple of cuts. I'm sure it's gonna handle it just fine. Yep. Do one more. There we go. 45 amps, not too bad on that. Definitely cut it just fine. Let's go up to 50. That's where it's at. Yep, on 3/8 mild steel, 50 amps does just fine. It'll do it with 40, but 50 works a lot better. All right, here we go. AHP Alphacut 825 until we fail. 7/8 of an inch. So after a short little cleanup by just hitting it with a hammer a couple of times, our dross fell right off. Well, let's go ahead and check with the camera up close here. That is 7/8 of an inch all day long. So, man, that machine's pretty powerful. When it comes down to it, that's a fairly straight cut. And, I mean, even if we turn it this way, you can see that's pretty straight. It's also pretty hot. So, this is pretty impressive to me. I've never cut anything this thick. I've never even tried, actually. But all in all, man, just to show how good that is, slight high spot in the middle, and the tail there and there is like a 1/16. And then up and down wise, it's probably got about less than 1/8 of an inch, probably 3/32 run out. It just kind of swooped off that way a little bit. I mean, wow. That's all I can say. Hopefully through the service of this video, you've been able to not only set the machine up properly, but operate it in a safe manner as well. The whole idea behind a plasma cutter, to be able to run it safely, efficiently, and not go through a hell of a lot of consumables, is to turn the heat up as much as necessary, but as little as possible. With that in mind, you should have a nice long life to your machine. But when it comes down to it, when you need that extra power, man, that 7/8 cut was impressive, but to me, not as impressive as that 1/2 inch aluminum. That takes a lot of power. And, well, the 825i delivered. I'm pretty impressed when it comes down to it. We didn't blow any fuses, we didn't have any problems, we didn't have any codes. The 825 didn't even stutter once. Now, obviously, we got some really rusty material here, and the starts and stops is safety measures that are built in the machine to make sure that you're not burning up consumables. So, I think it did everything it was supposed to. I hope you guys enjoyed this little video. Not only an unboxing, but talk about all the quality pieces of this fine piece of machinery. You can go forth with confidence. I'm your host, WhiteRiverRambo for Weld.com and the AHP Alphacut 825i. I'll see y'all on the next one.